Question number 3, part A. State the principle of conservation of momentum. So, by principle of conservation of momentum, first of all, we know that momentum is equal to mass into velocity. So, for principle of conservation of momentum, states that the momentum before collision is equal to the momentum after collision. Since the momentum is conserved, as it is conserved, so obviously the momentum before collision must equal to the momentum after collision. Then for part B, an object of mass 2m is traveling at a speed of 5 meters per second in a straight line. It collides with an object of mass 3m, which is initially stationary, as shown in figure 3.1. So the object of 2m moving at a speed of 5 meters per second, and the 3m is at rest or is stationary. And so this is before collision. After the collision, the object of mass 2m moves with a velocity v at an angle of 30 degree to the original direction of motion. So original path is the horizontal direction, but the 2m mass after collision, so this is before collision and this is after. So after collision, the 2m mass moves with a velocity v at an angle of 30 degree. So since it is moving at an angle, so we need to find its horizontal and the vertical component of velocity. So the horizontal component is v cos 30, that is for a right angle triangle. The horizontal side is cos, so v cos 30, and the vertical is v sin 30. Similarly, the object of mass 3m moves with a velocity w, also at an angle of 30 degree as shown in figure 3.2. So mass of 3m is moving at a velocity of w. Since it is moving at a velocity of w, so the horizontal component is w cos 30 and the vertical component is w sin 30. So this is after collision. Now, by considering the conservation of momentum in 2 dimensions, calculate the magnitude of v and w. So we need to find the value of v and the value of w. So first of all, to find the value of v and w, so since momentum is conserved, so the momentum before collision is equal to momentum after collision. So before is equal to after. Before is equal to after, but here we can see that initially the object is moving horizontally and after the collision the object is moving vertically. So before is equal to after for horizontal and before is equal to after for vertical. So first of all, for horizontal direction, we equate before is equal to after, that is we know that momentum is equal to mass into velocity. So mass into velocity before collision, that is 2m into its velocity, that is 2m into 5. So 2m into 5 plus 3m into 0, since the 3m at rest. So before collision, the 3m mass is at rest, so the initially it is at rest, so the velocity is 0. Then after collision, and we are now considering the horizontal direction. So after collision in the horizontal direction, so the 2m is moving at a speed of v cos 30. So moving at a velocity of v cos 30. So mass into velocity, that is momentum is equal to mass into velocity. So 2m into v cos 30, 2m into v cos 30 plus m into v w cos 30. So the mass 3m into w cos 30. So 3m into w cos 30, and this is not m, this is 3m into w cos 30. So this is for before is equal to after for horizontal direction. And since we need to consider the 2 dimension, so horizontal and for vertical. So for vertically, here we can see that initially there is no vertical component of velocity or there is no vertical movement. Since initially there is no vertical movement, so before the vertical movement is 0 or the momentum in the vertical direction is 0. So the momentum in the vertical direction is 0, and after the collision we can see that the vertical movement occurs. So momentum after collision in the vertical direction, that is 2m into v sin 30. So 2m into v sin 30 plus 3m into w sin 30. Now here we know that one is moving upward while the other is moving downward. So if we consider the upward movement as positive, then obviously we need to consider the downward movement as negative. So the movement downward is negative, that is negative. So that is the movement downward as negative. So the downward movement is negative. So upward movement is positive. So if you consider the upward as positive, then downward is negative. So the downward is negative. So we place a negative sign. So if we then solve, then 2mv sine 30, 2mv sine 30 is equal to 3mw sine 30. So 3mw sine 30. Then after solving, v is equal to 1.5w. Then we need to substitute the value of v in this equation, that is for the horizontal direction. After substituting the value of v, that is 1.5w, after substituting the value, we get the value of w as 1.924. There is approximately 1.9 as the value of w. And what is the value of v? So we need to substitute the value of w in the equation for v to find the value of v as 2.9. So we get the value of v as 2.9. So this is for 3 part B. Now for 3 part C, an object of mass 4.2 kg is traveling in a straight line at a speed of 6 meter per second. So initially it has a speed of 6 meter per second and the mass is traveling in a straight line. That is, the mass is traveling in a straight line at a speed of 6 meter per second, that is initially. Is brought to rest, that is the final velocity is 0 in a distance of 0.050 meter. So the distance s is equal to 0.050 meter and this is the initial velocity. Now calculate the magnitude of this force. So we need to find the value of force. So force is equal to mass into acceleration. So we know the value of mass, that is 4.2, and what is the value of acceleration? So to find the value of acceleration, first of all, we need to use the initial velocity. We know the value of initial velocity, that is 6 meter per second. Final velocity is 0 and the distance is 0.050 meter. So by using the equation v square minus u square is equal to s, so we know the value of final velocity, that is 0, initial velocity is 6, and the distance is 0.05. So what is the value of a? Acceleration is negative 360 meter per second square. So we know the value of acceleration as negative 360 meter per second square. So the acceleration is negative 360 meter per second square. So after substituting the value in the equation for force, we get the value of force as 1512 Newton. That is approximately 1500 Newton to two significant figures, and it is negative. Now here we can say that the force we have written here is positive, because here we can see that the object of mass is traveling in a straight line. The object is brought to rest. Since the object is brought to rest, suppose the object is moving in this direction, and since the object is brought to rest, that means there is some resistive force. Since there is some resistive force, that causes the object to be raised, and since it is a resistive force, so it is obviously negative. So the resistive force is negative, but when we write the value as the value of force, so we have to write 1500 as our answer. So the force is negative, but for the resistive force is positive. So the value of force is negative. So the force is negative, but since it is resistive force, so obviously the resistive force would be positive, because the resistive force itself is negative. The resistive force would be positive because the resistive force itself is negative. So whether it is positive or negative, we know that resistive force itself is positive, the resistive force itself is negative. Since the resistive force itself is negative, so we don't need to mention a negative sign. So the answer is 1500 Newton. And here are the three questions that is the you can use, that is s is equal to ut plus half at square, v square minus u square is equal to s, and v is equal to u plus at. So these are the equation for motion.